Greetings everyone, this is Mr. Mullen. In this video we're going to talk about ratios. What does a ratio mean? Now a ratio that you're really familiar with is density. Okay, what is density? Well, we love density. Density is something that we love. It's a ratio of the mass of an object divided by that object's volume, or how much space it takes up. And so let's say we measure an object and I throw that object on a scale, whatever it is, and it has a mass of 340 grams. And I'm able to do some kind of measurement to figure out that it takes up 120 cubic centimeters of space. So now I'm looking at this ratio, and I'm going to take the ratio 340 divided by 120, and I want you to tell me what that means. Well, those numbers have some unit corresponding to them. They're not just numbers. So I'm going to put the numbers on those. It's 340 grams. That's the unit of mass, divided by 120 cubic centimeters. There's my unit of volume. So what does this number mean when I'm talking about a physical object? Well, look at the numbers and the units. It means that 120 cubic centimeters of this object, when this object takes up that much space, there's a corresponding mass of that object, which is 340 grams. So that's what that number means. Okay? It has a physical meaning related to the units and whatever the numbers are talking about. Let's look at another example, maybe one that will make a little bit more sense to us. We go to the store, and I love Everlasting Gobstoppers, and I find that they have a box, 3 pounds of these things for $5. It's a deal. And so my question is, well, what is the meaning of the number 5 divided by 3? Because these numbers have units and they correspond to something, I'm going to put my unit on there so I know what I'm talking about. It's $5, and then the 3 goes with the pounds. So a lot of you may be thinking, well, what does this number mean? It means that it costs me $5 when I get 3 kilograms. Is how much I pay for 3 pounds of Gobstoppers. But what else can I do? So I have a calculator handy. So I go and punch that in, and I'm trying to figure out, $1.67. And then I divide that out. Remember, when we divide any number, when I do any division problem, I can always rewrite the answer as something being over 1 in the denominator. In this case, my units do not cancel. So that pound is still in the denominator. It didn't go anywhere. So when I look at this number here, I kind of simplify my ratio. The units are still standing. This has a different physical meaning. This means that for each pound of Gobstoppers that I'm getting, it costs me exactly $1.67. Maybe you've been to the store, you've noticed on one of those on the price tag, it will actually give you the price per ounce. Well, how did they do that? They took the total price divided by whatever unit they were measuring. So now I can look at my Gobstoppers in the box, and I can look at the bulk Gobstoppers and figure out which one's cheaper. So what I can do with this here is, this is telling me for each pound, or whatever my unit was in the denominator, that corresponds to some amount of, in this case, dollars in the numerator. Okay, let's take this another step further. So I want to take that same ratio and we're going to flip it around. Let's look at the ratio of 3 over 5. Okay, 3 divided by 5. Now, before I start just punching in numbers, I am going to deal with the units on here because those are important. So 3 pounds and $5. Those are the units associated with those numbers. So this is, you may say, okay, what's the physical meaning of this number? Well, for 3 pounds of Gobstoppers, it cost me $5 and vice versa. But let's divide it out. When I divide this number out, it's no longer 1.67, it's actually 0.6. But when I look at the units, I'm going to put that over 1. The units that are left standing, that didn't cancel, I'm going to find out that I have 0.6 pounds, and on the denominator is $1. So when I reduce this down, I still have that 1 on the bottom, and then some amount on the top. Well, what does this number mean? Well, this means that for each dollar that I spend, what happens? I get 0.6 pounds. What we can do with this number is we can make what's called a for each statement. So a for each statement is taking a ratio that's simplified and giving it a statement of a statement relating the two quantities involved. So for each $1 that I spend, I can receive an additional 0.6 pounds of everlasting gobstoppers. Or for each dollar that I spend, I get 0.6 pounds of everlasting gobstoppers. This is called a for each statement. So let's go back to our density example and look at those two ratios. 340 divided by 120. I'm going to put my units on there so I know what I'm talking about. And I'm going to also do this the reverse direction. When I divide those out, we're going to get two different numbers. So when I take my grams divided by centimeters, I'm going to get 2.83 grams on top. On the bottom, I still have my unit of centimeters cubed, and when I reduce that fraction down, I can always put a 1 in the denominator. So now I have a new way of looking at density. For each cubic centimeter of material, there is a corresponding mass of 2.83 grams. This is called the for each statement. Now we could do the exact same thing here, and we're going to get some number of grams for, did I mess this up? Okay, flip this around here. We could do the exact same thing here, and we're going to get a different value, and it's going to have a different physical meaning when I divide it out the opposite way. Because what's going to happen is we're going to have 1 grams on the bottom and some number of cubic centimeters. So in this case, it'd be for each gram of material, it takes up a space of blank cubic centimeters. So what is a ratio? A ratio that has been simplified tells us how much of the numerator is associated with 1 unit of whatever is represented in the denominator. And we're going to use this a lot this year with slopes. This has been a brief discussion on ratios, and I hope that this has been helpful.